In this lecture, we are going to discuss about the randomized algorithms. So what is the motivation behind the randomized algorithms? What are the different types of randomized algorithms? Then we will see how to solve few problems based on the randomized algorithm. Then we will compare them with the other deterministic algorithm, which will take more time and which will have more complex geometrical operations or mathematical operations. Basically, this randomized algorithm works on the a source of randomness, which will generate a random number. So basically, the random algorithms will depend on a source of randomizer, which will generate a random number. We use these randomized algorithms to reduce the time complexity or space complexity in a standard algorithm. But the output produced by this randomized algorithm may not be as optimal as any deterministic algorithms. When you have a time constraints or when you have space constraint, and if you don't bother too much about the quality of output, then you will go with the randomized algorithm. An error rate will be allowed here in the randomized algorithm. That depends on what randomized algorithm you are choosing, whether you are choosing Las Vegas randomized algorithm or some other randomized algorithm. It depends on what kind of randomized algorithm you are choosing. And this randomized algorithm will also help the brute force approach by sampling the input and in such a way that the output generated may not be an optimal solution and the output will be up to a satisfaction level. And this random sampling is a variation of randomized algorithms. Okay, so you can consider this one as an example for randomized algorithm. To explain this, you can take an example of polling survey. For example, if election is happening throughout the India, and if you want to survey and if you want to predict the outcome of elections, then what you can do is you can randomly you can pick some samples in different geographical locations, and you can compute the final output. Okay, and most of the surveys are doing the similar way. Okay, what they will do is they will take random samples from different geographical locations, and they'll calculate, they'll do some computation, and they'll predict the result of election. Okay, and the result of this poll survey may not be true all the times, but they will give at most accurate. Okay, and so what they will do is they will pick some sample voters from different states and different geographic locations from different community and different caste, and they will do all the mathematical calculations and they will give a result, and that may not be accurate all the times. Sometimes, okay, they will predict with some error rate. If you want to take a survey for all the peoples in India, and the time may not be sufficient enough and the manpower is too much, okay, and so that's why what we will do is we will not take survey from each and every voter. We will take survey based on some random samples. Poll survey is one area where you can depend on the random samplings, which is a variation of randomized algorithms. So what is different between deterministic algorithms and randomized algorithms? In deterministic algorithm, the output will depend on exactly the inputs. The output as well as the time taken to generate this output will depend only on the input. Okay, if I give same input twice, and I will get the same output. Okay, if I give same input 10 times I will get the same output in the same time period. But in randomized algorithm, the output will depend not only on the input, it also depends on the random number generated by the random source, by the randomized algorithm. Okay, whereas in deterministic algorithm, the output will depends only on the input. For the same input, if you give multiple times, you will get the same output in the same time period. But whereas if you work with the randomized algorithm will not only depends on the input, the randomized algorithm's output will depends on the input as well as the random bits generated with the random algorithm. Okay, so it will give different results for the same input. Okay, that result will vary. That result will depends on what random number generated by your randomized source, and the time also will vary for the same input in different time intervals, because in each time interval the random number will be differ. Okay, and we will explain this randomized algorithm with an examples, and this is one example where randomized algorithm will be better when compared to deterministic algorithms. Let us say if you have 10,000 elements, and if you want to find out the median, out of 10,000 elements, so basically what we will do is using deterministic algorithm, we'll sort all these 10,000 elements, and then we'll pick the medium one, the one which is in the middle we'll pick. Okay, for that one you need to sort 10,000 elements. So instead of sorting all the 10,000 elements, what we can do with the randomized algorithms is, instead of sorting all the 10,000 elements, we'll select random samples out of 10,000. Let us say those samples are C log n. We will not select all the elements to find the median. Instead of taking all the elements to find the median, what we will do is, we will take only the C log n number of elements, and we will sort those elements, and then we will find the median. Okay? So this result will give an approximate result, and this may not be true all the times, but it will give an approximate result. And the time taken by this is very less when compared to the deterministic algorithm, where you need to sort all the 10,000 elements. So what we will do is, randomly we will choose some k elements, where k is equal to C log n, where C is any constant. Okay? The output will depends on this C constant. Okay? If the C is lesser and your accuracy is less, if you keep increasing C, then the accuracy will be more. So accuracy levels of your algorithm will depends on what constant you are choosing in place of C. So choose C log n number of elements from the total n elements, sort them and choose the middle element. So this is one example for the randomized algorithm, where we need not to work with all the 10,000 elements, all the n elements. We will work only with the C log n elements, we will sort them and we will identify the median element. So this is one example for the randomized algorithm. The total time taken by this randomized algorithm is log n log n. Okay? And the next one is the randomized quicksort. The randomized quicksort is also an example for randomized algorithms. The process of selecting a pivot element, so we are going to make it as a random. Okay, we are going to select pivot element randomly. So this is called as randomized quicksort algorithm. In randomized quicksort algorithm, we will select a pivot element randomly. So initially, if the list contains only one element, we need not to perform any sorting. Basically, we will terminate the sorting process here itself, and the first step is to check whether the list contains at least two elements or not. If the number of elements is not even 2, then we will terminate the process of sorting here itself. Otherwise, we will do like this. Okay? So what we will do is, randomly we choose x as the pivot element. We will check whether the number of elements to the left side of this pivot element is at least 1 by 4. We will pick a random pivot element, and we will check whether the number of elements to the left of this random pivot element is at least 1 by 4. Okay, if the number of elements to the left of this random pivot element is not at least 1 by 4, what we will do is, we will keep repeating this process until we get at least 1 by 4 element to the left of this random pivot element. And all these elements should be lesser than the pivot element, and all these elements should be greater than the pivot element. All these 3 by 4 elements should be greater than the random pivot element. Okay? Okay? You choose any one pivot element called x and check whether the left side of x contains at least 1 by 4 elements. All these 1 by 4 elements should be lesser than x, and all the elements to the right side should be greater than x. So you have to select that pivot element. Okay? If the selected random pivot element does not satisfy this condition, you select one more random variable as pivot element and do the process. So you have to do this process until you get a required pivot element. Okay, until you get required pivot element, you keep repeating the process. So whenever you get a pivot element that satisfies this condition, then go to the next process and partition your array into two parts. So one partition is to the left of x, and one partition is to the right of x, and then perform again the quicksort on the left side as well as the right side. Okay, this is the way how the randomized quicksort algorithm works. The difference between this deterministic quicksort and randomized quicksort is, and here we are not performing complex operations to choose the pivot element. First we will check whether a list contains at least 2 elements required for sorting. Once you know that the list contains at least 2 elements, so what you can do is, The next target is to choose a pivot element. How we will choose a pivot element? We will choose pivot element and in such a way that the number of elements to the left of pivot element is at least 1 by 4 which are less than x. Okay? If the randomly chosen pivot element does not satisfy these conditions, you go with another random pivot element and keep doing this until you get a valid pivot element. So once you find the valid pivot element, then you divide this list into two parts. One is to the left of pivot element, another one is to the right of pivot element, and solve them separately again using the same quicksort algorithm and follow the divide and conquer approach. If you observe this, this second step will take a maximum of order of n times. So why it is maximum of order of n times? Because a list contains a maximum of n elements and you have to choose one element out of n. Okay, so there is probability is n elements are available and you have to choose one out of n. So the maximum time taken by the second step is order of n. Total time taken by this randomized quicksort is order of n log n. Okay, this randomized quicksort will take order of n log n. In the best case it is order of n log n, in the worst case is also order of n log n. The generalized quicksort also will have the same best case time complexity as well as worst case time complexity. So this is another example where you can use randomized algorithms. There are two kinds of randomized algorithms. One is a randomized Las Vegas algorithm and another one is a randomized Monte Carlo algorithm. The algorithm the random algorithm you are choosing for your problem, it can be any one of these two, depends on what kind of problem with which you are working. If you want to have an exact output and there is no space for errors, then go with the Las Vegas. This Las Vegas randomized algorithms will give you the exact output, okay, and it will not give you any incorrect output, it will give you the exact output and no errors are allowed. But the problem is the time is unbound. The time taken to find the exact output is unbound. It can be infinite. Okay, it is not limited. You cannot say that within this time frame I can find the solution. There is no exact time frame within which you can find solution by using the randomized Las Vegas algorithmic approach. Okay, you will get exact solution, but you don't know when you are going to get it. Okay, and the time required to find the solution is unbounded. Okay, but you can make this as bounded by limiting the number of iterations. Basically it is unbound, okay, it will take unbound time. The time taken to solve a problem is not limited, not bounded. But these unbounded algorithms can be converted into bounded by limiting the number of iterations, then by limiting the number of tries. Okay, so what you can do is you can put a threshold. You can put a threshold like t. Once you reach t number of trials, you can stop the algorithm. You can say that there is no. The answer is no. If your problem is yes or no problems, kind of things, decision problems, whether to produce yes or no as your output, what you can do is you can convert this unbound randomized algorithm into bounded randomized algorithm, and you can keep a threshold. You can keep a threshold t. Okay, you try to check whether you can able to get yes answer until you reach t number of iterations, t number of tries. After trying t number of iterations or t number of tries, still if you are not able to get yes, then produce the output as no. Okay, so the number of tries or the number of iterations exceed a threshold, simply produce output as no. Okay, but it may not be true all the cases. So there is an error. So when you are trying to convert from unbounded to bounded, there is a probability for error because you are assuming that the answer is no after reaching t number of tries. Okay, so this is the Las Vegas algorithm where you will get the exact output, but the time is not fixed. Okay, you cannot predict what is the time bound in which you can get the exact solution. Whereas this Monte Carlo algorithm is a bounded randomized algorithm. Okay, you will get output in a fixed time interval, and the output is not going to be exact value. Okay, it's an approximate value, and here there is a chance for error. If you go with Monte Carlo randomized algorithm, there is always an error, and you can use these algorithms if you allow error up to a certain limit. And here this randomized algorithm will produce output in a fixed time interval. It is up to you to choose whether randomized Las Vegas algorithm or Monte Carlo randomized algorithm, depends on whether you need the exact output or an output where you are allowed a fraction of errors. We have deterministic algorithm for the most of problems, then why still we are going for the randomized algorithms? The reason why we are going for the randomized algorithm, it's very simple actually, and they are more efficient than the deterministic counterpart. The reason is, so assume that if you want to find out a median element in 1 billion entries, so basically by using deterministic algorithms, what you can do is, you can sort all these 1 billion entries and then you can choose the middle one. But sorting 1 billion entries will take lot of time, okay? Sorting these 1 billion entries will take lot of time. So what we will do is, instead of finding the median element in the 1 billion entries, what you can do is, you can take a sample of like 1 lakh, and you can find the median in these 1 lakh entries, and you can predict what is the median element out of these 1 billion entries. This is similar to the example that we discussed earlier. If you want to predict who is going to win in the next election, it is not possible for us to go and ask each and every voter to which party you are going to cast your vote. So in India we are having around 120 crore people. It is not possible for us to reach each and every voter and to check which party he is casting his vote. Basically all the survey agencies, they are not asking all these 120 crore people. So what they are asking is, they are taking a sample of around 2 to 3 lakhs from different states and different geographic locations, different religions, different caste, and they will predict the winner from these 2 lakh people. You can analyze that most of the poll surveys is almost true. Okay. So this is one reason why we are going for the randomized algorithms. Okay, which will reduce the time and space required for solving the solution drastically. Then another example where we can use randomized algorithm is, assume that you have a set of points. Let us say this is 1 point. Assume that you have a set of points. Assume that this set of points, and the smallest enclosing circle problem where we can use randomized algorithms. We have deterministic algorithm also. You will have a set of points. You have to identify a circle which will cover all the points. So for example, if I draw a circle like this circle is not covering all the points on the plane. Okay, then we will go with another circle and try whether it will cover all the points. Then try with another circle. So instead of going deterministic algorithm, what you can do is, you can randomly draw circles and you can find out whether this circle covers all the points inside or not. So this is one problem where we can go with the randomized algorithms. The Megiddo solved this problem in 1983, and the time taken to solve this problem is order of n if you follow this Megiddo approach. Okay, so Megiddo has already solved this problem in 1983 through a deterministic approach. Even if you use randomized algorithms, it is not going to take more than order of n time. This Megiddo will use complex geometric operations, and we will not use complex geometric operations in our randomized approach. We will use very basic elementary geometrical operations in our randomized algorithm. Both will have order of n time complexity only, but the second one, the randomized algorithm, is very simple and it will use very basic geometrical operations. So this is one algorithm where you can apply this randomized algorithms. And there is one more problem called as minimum cut, where you can apply randomized algorithms. So what is this minimum cut problem? You will be given a graph consist of vertices and edges. You will be given a graph consist of vertices and edges, and the objective is find a minimum set of edges that will divide your graph into 2 halves. So you have to find a minimum set of edges which can make your graph disconnected. So for example, if I cut this edge, still the graph is not disconnected. If I cut this edge also, then the graph will be disconnected, and this is one cut and this is another cut. So for this problem, the minimum number of edges need to disconnected to make this graph as disconnected is 2. So this is the minimum cut problem. The objective of minimum cut problem is you have to find the minimum number of edges which can be discarded in such a way that the graph is disconnected. So here also you can apply randomized algorithms. Warner identified the solution in 1997 itself, and the time taken to solve this problem by using this deterministic approach is order of mn, where m is nothing but number of vertices and n is number of edges. The same problem can be solved by using the randomized approach in order of m log n time with the help of Monte Carlo randomized algorithm. Okay, and the time complexity is much better when compared to the deterministic approach. Okay, so how it works? It is very simple. So assume that you have a graph like this. You can apply randomized algorithm on this. Choose any one edge randomly and merge both endpoints of both endpoints. So for example, let us choose this edge. Let us choose this edge. Choose any one edge randomly and merge both endpoints of that edge. So I choose this edge randomly. So what I can do is I'll merge these 2 points like this, like this. Then again choose one more edge, then again choose one more edge and merge these 2 points, and again choose one more edge and choose the end point. So you have to keep doing like this until there are only one edge is possible. So like that you can find the minimum number of edges in such a way that your graph will be disconnected. So by using the randomized Monte Carlo algorithm, and whose solution will take a maximum of m log n time. As I said, it is a Monte Carlo. There is an error also. Okay, the solution will contains error also, and this error is n power minus c, and minus c will depends on the constant you choose when you are doing it. Another problem where you can use randomized algorithm is primality testing, where you need to find out whether a given n bit integer is a prime number or not. Okay, you can use this problem in different areas. So one is cryptography and algebraic algorithms. Okay, this is one of the important problem to identify whether a given integer is the prime number or not. This is called as primality test. So for this one, there is a deterministic algorithm proposed by Agarwal in 2002, which will take order of n power 6 time complexity. Okay, you can solve this problem by using again the randomized Monte Carlo algorithm. Okay, and the time complexity you need, the time you need to solve this problem by using randomized Monte Carlo is order of k n square, which is much better than this deterministic algorithm proposed by Agarwal, Kayal and Saxena in 2002. As I said, it is a Monte Carlo algorithm. Still there is an error rate for this one. It is 2 power minus k, and that k will depends on what k value you are choosing for this when you are solving using a Robin algorithm. Most of the people will have uncertainty whether should I go with the randomized algorithms or should I go with the deterministic algorithm, because as I said, the randomized algorithm will have some error rate. Again, it depends on you whether you need an exactly accurate output or not, whether you are allowed error rate to a certain level. And one more thing is to encourage the use of randomized algorithm, a study published by Microsoft in 2008 states that if you run a CPU for 5 days, the probability a CPU will fail is 1 by 330, and your CPU will fail one time for every 330 runs. Okay, so if you convert that into number of seconds, your CPU will fail 10 power minus 9 times for every 1 second. 1 by 10 power 9. The probability of a CPU failure for 1 second is going to be 10 power minus 9. But if you observe our problems which we discussed earlier, their error rate is much better than this 10 power 9. Okay, their error rate not as much as your CPU error rate. In real world, you can allow errors up to a certain limit. If you compare this error rate with the algorithms we discussed earlier, and the error we received for the different problems is not even as much as this 10 power 9. So for example, let us take this finding approximate median value. If you run this randomized approximate median finding algorithm, and the error rate for 1 million entries is 10 power minus 12 only. Okay, if you run this randomized approximate median finding algorithm for 1 million entries, and the error rate is 10 power minus 12, which is very less than what our CPU failure rate. And one more encouraging example for this one is one more encouraging example for this randomized algorithm is, if you run this primal test, for 50 values, and the error rate is only 10 power minus 15, which is much lesser than what you are getting for your CPU failure rate. Okay, so for the 1 million values where you find the median, the error rate is 10 power minus 12, and for primal test it is going to be 10 power minus 15, and these two is much lesser than a 10 power minus 9 which you are getting for your CPU failure rate. When you don't have sufficient time to find the solution, go with the randomized algorithm. When you don't need accurate exact results, and if the errors are allowed to a certain limit, go with the randomized algorithm. Okay, so far what we discuss is, we discuss what is randomized algorithm, why we need to go for randomized algorithm, what are the different types of randomized algorithm, some examples where this randomized algorithm is applied and their time complexities. Thank you.